My name's Rick Busbridge. I'm currently working for NICTIS in the Netherlands. NICTIS is our national sort of organisation for standardisation in the Netherlands, healthcare standardisation. We sort of manage and help develop the national standards that are being used. And of course we have an interest in what's going on in Europe, because essentially we're going to align the Dutch approach on the EU approach. So we do quite a lot of work on both the national and European context here. Which is it to push, the spacebar?
No, the
okay.
arrows, yeah.
Okay, just very briefly, this is a bit of a teaching session as well, as our recommendations. So very, very briefly, we're talking for this short section on the cost manifest and some recommendations that have been put together by the Mult-Country working group. And just as a very brief background, there's a couple of slides here just to talk about what a key object selection entity is in DICOM. And as Charles has pointed out, DICOM actually has a very secure standard model for imaging, where the underlying images belong to a series of images, which could be one image up to tens of images, hundreds of images, belong to a series, and there can be a number of series within a study, and typically a study belongs to a given patient. At each of those levels, there's different kinds of attribute data that can be stored relevant to that appropriate level. The main thing that's important from the cost point of view is that each of these levels has an identifier associated with it. And from the study series down to the instance, we talk about UIDs, instance UIDs. And it's very important to understand that you can actually build the hierarchy of a set of images up by mapping the UIDs into a structure like this. So you can actually get the relationship of the underlying images that were captured. The images themselves are composite, meaning that each individual image stands alone. It has patient information in it, it has study information in it, series information, and image information. So each individual image in a DICOM study can be separated, is actually sent as a separate entity between two systems, and it's only on receiving a number of these images into your packs, for example, that you can extract the relevant identifiers and rebuild the structure of the underlying study. So that's important to know as a starting point. To talk about the cost object selection, it's a means of identifying images, underlying images, by their identifiers, and using that relationship for a given purpose. And there are a number of reasons why you might want to use a selection document. And there's a table actually here that identifies on the top there the kinds of reasons or the purposes to which a key object selection document could be used. It also allows you to identify the location of your studies, so you'll actually know where is the source of my data. That information will be included. And I just want to, because we're talking about a manifest and a key image note in this discussion on the recommendations from the Mult-Country working group, I just want to introduce the costs as would be used for those particular use cases. And if we take the underlying study here as an example, we've got a single study comprised of 3 series. Each series has a number of images in them. This is our basic study. When it comes to creating a manifest of that, we may want to describe the whole structure of the study, meaning that we actually want to point to all of those images that are available in the study. And what we're going to do then is create a cost document that will identify that. So the first thing we do is we create an imaging study manifest, and we identify that by its title. So there's a title that is used for each cost object. In that, you identify what the purpose is of the cost. In this case, it's a manifest. And then you identify the relationship of the images that you want to store in the manifest. So what we're essentially doing is we're copying the unique IDs out of our tree structure up there into the content of the cost document. So essentially, you've got a document that's encoded in a DICOM format that contains a title which identifies what kind of cost it is, what is it actually doing, and the relationship between the images that you want to then describe. And as I said, it also contains a location. So inside the manifest, you'll know where do I find these images, in which source system are they, in which PAC system. It could be that one series is in one in another. Who knows how these things have been distributed. So that's the manifest version of a COS. And what you end up with then is, by creating that, you end up with, at the series level, another DICOM object, which is in fact the manifest. So within that study, you've got the underlying series with all the descriptions of their images, and a second, in this case, a fourth series that contains the manifest itself, which is the description of the underlying study. The second possibility for this is to use a COS to identify significant images. By significant images, Charles has mentioned this, that there may be images within a series that are of interest for a given reason. We want to highlight that fact. And so in that case, you could say, okay, there's, out of my 3 series here, there are 4 images which are significant, and I would like to highlight that fact to any recipient of this study. So anybody viewing the study will immediately be notified, oh, pay special attention to these 4 images for whatever purposes. There could be a tumor that's more easily visible in an image, etc. So there are reasons why you'd want to identify them. And essentially, you do exactly the same thing. This time, the title of the COS is actually given as being a COS describing images of interest. So it becomes a key image note. And here we then include the structure, the unique identifiers of the structures that are of the images that are then of a key interest, of a significant interest to us. So again, we create that, and what that does then, it actually creates, if you were to build this COS-kin, we'll call it a COS-kin from now on. If you were going to build that, you would end up with a series containing a DICOM COS-kin object, which points to the underlying images in your study of interest. And so that study now comprises not only the images, but also the key image note. And those are two use cases, or two typical applications of a COS object. And both of them, of course, any COS is encoded in DICOM, so it belongs with the DICOM study, the underlying DICOM study. That's important. So moving on from that, bearing that in mind, what the COS is, then, as Charles said, we've got two recommendations that I just want to talk about. The first one is actually the recommendation on the manifest, and the second one will be on the significant images. So on the manifest, we've developed, as I say, you can see the context of the use of the manifest, explain the choices of the DICOM COS, refine the content of imaging study manifest in areas such as patient IDs, accession numbers, etc. And what we're trying to do with these recommendations is fill some of the gaps that there may be in the current descriptions. So if you read either the DICOM standard of what a COS object is, if you read some of the IHE framework documentation, there could be slight gaps in some of this. And what we're trying to do with MCWG is to fill those gaps with clear recommendations on how you should proceed. And so we have a version of this which was completed, as Charles said, in fairly record time. There is a link here onto the actual document itself. And we base this again on the underlying EHN guideline. So we're using the imaging guideline. There is a definition of an imaging manifest in that guideline, and you can read it for yourself. It's listing the key information about the content, so we know what the content is. It also tells us, because the images themselves, if you want to move images around, they're huge compared to other kinds of documents. If you're talking about an imaging report or a lab report or a patient summary, typically they are the order of maybe megabytes of data. Images themselves, studies, are hundreds of megabytes, even gigabytes. So it's a completely different order of magnitude of information. And so in order to understand the structure of the underlying study, a manifest is used. And as I say, the manifest allows you then to identify the structure and content of it, and also provides the pointers where you've got then the locations of where these images can be found. So that's the formal definition of the image manifest from the EHN definition. As Charles has already mentioned, we take we've gone through the use case, and there are 5 essential steps, if you like. Step 4 is a discussion on the imaging manifest, so the retrieval of the imaging manifest and the content of that. So I just wanted to reference or to relate the position of the imaging manifest into the discussion that we've had on the use case so far. What we did as part of this discussion is to look at what is the state of the art at the moment, and try and bring that experience and so on into our recommendations. And as Charles has pointed out, there are 2 discussions, or 2 candidates for some kind of manifest. One of them is the DICOM key object selection document, or the other alternative is a FIRE document bundle using the imaging study resource as the pointer to the images, etc. What we did within the Mult-Country working group, we had quite an in-depth discussion amongst members based on experiences, based on the breadth of adoption here, the implementation adoption, which is then something that we can concretely measure at IHE Connectathons and so on. We actually know during the IHE Connectathons which products are supporting what kind of profiles, what kind of entities underneath those profiles. And there it's quite clear that when we look at the comparison then on between the DICOM COS and the FIRE imaging study, currently the state of the art as of today and what we know about is that there are far more systems that support a DICOM COS than do the imaging study. And so from a maturity point of view and adoption point of view, it's by far the leading technology. There is a FIRE R4 version of the imaging study, which has a maturity level of 3, and it's in trial use at the moment. And the little text at the end there says it's not yet seen widespread use in production across the full spectrum of environments. So it's an unknown, essentially. We just don't know. And so based on the state of the art, the choice has been made to go for the DICOM COS. The content match is pretty much the same between the 2. There's about 90% of the attributes that are identified in the EHN guideline as being necessary for a manifest are covered in the standard variant of the DICOM COS and the FIRE imaging study. The other category that we looked at is how do we actually use this thing? What are we using it for? And typically, the manifest is used in an imaging environment. Imaging environments are, by default, DICOM. They have a DICOM stack to parse the contents, to use that contents, to encode the contents, etc. So in terms of imaging, a DICOM COS object aligns very well into that DICOM stack. It is a DICOM object, so you can parse it, you can extract information, you can create them, etc. So based on that, the recommendation is to see that on those 3 categories, at least, the overall match is for the DICOM COS, and we've chosen that. We recommend that as a way forward. What we've then done, and this is an abbreviation of the full slide deck. I think there's about 30, 40 slides in the slide deck on the recommendations. We've talked about some of the missing attributes that we feel should be added to the standard definition of a DICOM COS. We add those in as essentially optional attributes in terms of DICOM. We don't want to break the DICOM standard, so we have to be very careful in terms of adding information in that wasn't there originally. So we can't mandate the use of these kinds of attributes in the formal DICOM definition, but what we can do is say that we recommend that these attributes are used. And IHE have done this as well in their use of certain DICOM fields, certain DICOM objects. They've made recommendations that slightly enhance the use of a standard DICOM object. So here, for example, if you imagine what Charles said is when we're looking for information, we're trying to find, we're discovering what studies are available in country A for the treatment purposes in country B. We start off with a query, high-level query. We get back a list of matching entries. We get back a list of studies, list of reports that match, say, the modality type, the body part that we're looking for. And when we get the matches, what we'll get back are reports and imaging manifests, imaging study manifests. The data that's available inside the imaging study manifest, if we parse that, we can pull out things like a series description, or sometimes the modality type. And that allows you, if you display that to the user, it allows the user then to make a selection between retrieved manifests to know which one is the one that's of interest. So that would then allow you to make your choice of how am I going to, or which study part am I going to retrieve. So we recommend the addition of, I think it's five or six attributes here. At an instance level, so this is down at the imaging instance level, we recommend that the number of the instances included. So in a standard COS object, you will always have the unique identifier of the image instance, but we recommend that we add in there the numeric value. Is this image number 1? Is it number 2, number 3, etc.? And should the image be multi-frame, then we recommend adding the number of frames. A lot of this is simply for the consumption purposes, that we can knowing this information at the level of the manifest means that we can set up the context of a viewing application, for example. We know how many images are going to be. We know how many frames there may be. You can start to reserve resources in your viewing application to account for that. So these additions are simply to enhance the use of the manifest. We're not trying to duplicate every single attribute that's there, but we just feel that these things will make the use of the manifest more useful and more practical. There are a whole load of other recommendations in this, including the fact, and as Charles has pointed out, in the first recommendation we have a standards positioning, which based on the national and regional infrastructures, we identified the kinds of IHE protocols that could be used, IHE profiles, sorry, that should be used. And we know that in existence today we have XDSI domains, we have XCA. We're moving moving the ability to use FIRE, we'll have an MHD domain. So we are saying that the use of this manifest can be deployed across any of those profiles. We're not saying that it only applies to the use in XDS, for example. We talk about some recommendations on the patient identification, and that's another key topic. If you're talking about local systems, typically you have a local patient identifier that's known within your own hospital. If you move that image then to a regional level, it may be that you need to include a regional identifier. When we go to national and then cross-border, we have to include a national identifier. And we give some recommendations on how that is done within the DICOM identification scheme that you have. DICOM particularly only allows the primary identification of one identifier, and we recommend that is then the national identifier, and any other identifiers that are known for a patient should then be copied into a sequence of alternative identifiers. Charles mentioned the links between reports and studies, underlying studies. So these are sort of workflow identifiers. Obviously, if you do a request and you retrieve, you get back some reports and manifests, you've got to be able to link those together. They won't be automatically linked together. They'll come back as separate query items, and it's up to you then to look at the accession numbers, order numbers, etc., to build the relationship between the items that you've retrieved. We talk about publication strategies, for example. When are you actually going to publish your manifest? At what point? Do you publish it immediately that your study's complete, or do you wait, for example, until your report's been approved? There are different strategies. We mentioned that in the recommendations. Also on the location and retrieval, there are identifiers inside the manifest which allow you to either use a URL, a direct URL, which will apply to the series level. There's a retrieval mechanism at a series level in manifest that can be used directly to pull back images at series level. There is also a location ID or UID that could be used via some kind of addressing function to get the endpoint where you're going to find your studies. We talk about some recommendations on the use of common DICOM storage SOC classes, meaning here the more common types of images that you have, because we want to make sure we have the basic interoperability. So we want to make sure that if you have some CT images, MR images, ultrasound, that your viewing applications can view them. That not some obscure kind of SOC class that may be used in a department. It may not be possible that even if you can pull that information back, that study information back, it could be that your viewing application simply can't display that kind of SOC class. So we talk about the use of more common, the recommendations on the use of more common attributes. There's also the time zone offsets, which Charles already mentioned. It's very important if an image is taken in one time zone, that we can relate that to the time zone that we're actually working in. Oftentimes you find that the images that were created by the modalities don't take time zones into account. They just simply produce images. They will stamp them with the date and time that the images were created. But what we're saying is here that we will recommend that a time zone offset is added into the manifest that is applicable to all the underlying images. So you can actually use that to update your times in the underlying or referenced instances. And there's a section on the selection of significant images as well. We talk about the need to have that ability in the manifest, or that you should be including that. So that moves me on to the final section today, which is actually on the significant images themselves. And what we have here, if we go back to our study, we can see, okay, we pointed out there were 4 images that were significant, that are of interest to us. We've created the COS-KIN for that, so we actually know, by looking at the structure of the study, we know that when we access that COS-KIN, that's actually going to tell us which of the images in our whole study are of interest, are significant. So that looks fine in itself. We can do that today without any problem. We have all the tools we need to do that. But what's the actual problem then? And with the reason we've addressed this, sorry, I should have pointed out, the reason we've addressed this, it is one of the preconditions to the use case for the EHN guideline, that there should be the ability to identify the relevant and significant images. So we're bringing this in as part of some work done by one of the focus groups in the Mult-Country working group to address a mechanism that can handle this. And the actual problem itself is that this is fine. We can do this now as with today's technologies and stuff. But the problem is, how does this work when we start to share that information and in an efficient way? So what we want to be able to do is to share our studies by learning as much about them as possible, by retrieving as little amount of information as possible. So what we're saying is that by including some additional information in the manifest about the significant images, you can reduce the retrieval needs to understand which images are actually significant. And what we mean by that is that if this is our structure of our manifest here, we've shown that there will be, COS-KIN is one of the objects in the study. It's actually identified in the manifest as belonging to the study. If we add a couple of attributes to the data in the manifest, we can actually point to the COS-KIN from the underlying images and identify which of the images are significant. And that means that instead of having to retrieve the manifest, then identify from the manifest which of the objects are COS objects, retrieving the individual COS objects, working out which of the COS objects is a KIN, a key image note object. So this is all requiring additional retrieval activities, additional processing. By putting some of that information into the manifest as an extension, we can avoid all of that extra traffic and overhead. So essentially what we've done then is said that in these recommendations for the significant images, we propose that as the description of the underlying image is part of the manifest, if that image belongs to a COS-kin because it's seen as being significant, then we're going to put a pointer in that image to reference the COS-kin itself as an addition to the manifest. And also what's possible, you can identify images as being significant, but you can also identify the reason why. There's a free text that the radiologist can actually enter to indicate why this image is significant. And what we propose to do is put that comment into the manifest as well. And what that then allows is that once the manifest has been retrieved, the contents of the manifest can be displayed to the user, including a highlight of which of the images in a series are significant. And that may mean that the user decides to retrieve that series as opposed to any other series, or possibly even retrieve individual images. It could be that the user decides to say, okay, rather than retrieving the whole series, I'm just going to retrieve the images that are noted as being significant in the use case that I'm dealing with at the moment. So, again, technically, this addition has been done by adding some optional attributes. I won't go through them in detail, but the specification of the attributes has been made. The attributes we think we need have been identified, and a description of those attributes is produced for the linkage back to the manifest, and a second addition for copying the comment that may have been in a manifest, in a kin, into the manifest. So that's a fairly small addition, a recommendation to add some attributes to the manifest, but the purpose and the benefits from doing so, I think, are fairly significant. Sorry for the pun, in the sense of it will allow you to identify significant images without the necessary overhead of retrieving additional items. So that's the two sections I was going to cover, Charles. I think you're going to wrap up the MCWG work.
Yes.
And I'll speak about the European stuff a bit later on. Thank you.